Welcome back, students. In the last class we were discussing about the geotechnical engineering's consolidation chapter. So, we will continue with the same chapter, but now we will brush up our concepts, use all the formulas etc. by solving the problems on them. Okay, so let us start with today's lecture. So, first of all, we will generally go through the numerical techniques and to find the consolidation. Mainly we will deal with the settlement and time of settlement, two parameters. We will calculate these two parameters in this lesson. Okay. So, directly let us go to the numerical. Again, read the question carefully. The subsurface profile of a proposed site of construction is shown below. A square footing 2 cross 2 carries a load of 1000 kilonewton and is laid with its base at first depth below the surface. Assuming that the post construction settlement in the sand is negligible, determine the consolidation settlement of the clay layer. Remember, the settlement for the sand layer is considered to be negligible. Why? Because consolidation settlement cannot be considered for sand, you know already, because it is the sand has a instantaneous settlement. I am sorry. Okay, so no consolidation settlement can be considered for this. So, since this sand will not be considered, so we will only be considering the clay layer for this question. There is geological evidence clay is what is this NC? NC is normally consolidated. Okay. NC means normally consolidated. So, the clay is now also given that it is normally consolidated. Use two vertical and one horizontal dispersion. Okay, we will understand what is this to estimate the stress increase in the clay layer. So, now this was the question. Let us move to the diagram. This is the diagram. You can see, okay, this is given in the question itself. We have three layers: sand, sand, clay. In the question it is already given that these sand layers won't be going and undergoing any consolidation settlement. Okay. So, we are mainly concerned with this clay layer only, but remember, always during the settlement, to find settlement, we always consider what? The middle. Okay, we do always consider the middle of the given clay layer. Okay, what does this mean? Remember this point. This means that we are already given with the three layers. One is sand, the second is also sand, and the third is the clay. Remember, we will be finding out the settlement at the middle of this layer, at this point. This point means depth will be 1.5 meter only, total is 3. So, at halfway we will be finding out the settlement, which is 1.5, this much will be 1.5 now. Okay. Always in the case of settlement we will use the same concept. Okay. Besides, you are given with the gamma for sand here, this is water table here, which means this is saturated. Okay, saturated, or precisely we can say that fully saturated. this is fully saturated here, and this part is also fully saturated only. Okay. So, these and this both the layers are fully saturated, first point. Second point, remember this layer and this layer is 2 meter in width, okay, and this is also 2 by 2, it is a square already written in the question. But while calculating for the dispersion of the load, we will consider from this part only, this level. Okay. How much is this? This is 1, then how much this will be? 1 meter. Okay. So, now let us further proceed, then we will understand the other concepts. Now, first of all, what are given to us? The Wn and Wl, both of them are given to us. Okay. What does this Wn? Natural water content. This is the okay, and what is Wl? This is the liquid limit. Okay. Cc, if you remember, we discussed this one is for undisturbed clay. For undisturbed clay, the Cc formula was 0.009 Wl minus 10. So, Wl is given here 60. So, just calculate, we will get Cc value to be 0.45. Why we calculate Cc value? Because if you remember, you might have been remembering this formula, Cc into H naught upon 1 plus E naught log sigma naught and sigma 1, you can say, for the time being. Okay. This formula we will be using in this question to find out the settlement, okay, of the clay layer. So, for this Cc was required. So, we have calculated the Cc. First part is over. H naught we already know. Okay, H naught we already know. What is the value of H naught? It is the initial thickness of the clay layer, which is 3 meter. E naught, we do not know E naught. Now, the second step will be the finding of E. Okay, this is the E naught only. So, what formula we are using? S into E is W into G. So, for this, these three parameters are required first. So, you can see in the question what are given to us. You can see that Gs is already given to us, first thing. Okay. You know this is already fully saturated because the water table was here. This means this is also fully saturated. What does fully saturated means? This means S is equals to 1. Okay. S is equal to 1 and G is equals to 2.7. So, in this question W is also already given to us. So, G we know, S we know, W we know. So, just find out E. Okay. E we get out to be 1.08. So, now we know this and we know this. Now, we are to find out this only. What is this? This is the initial and this is the final. Okay. Final stress at mid layer of clay. Okay. And what is this? Initial stress. Initial stress at mid layer of clay. Okay. So, these are the things here. Now, how we will calculate these two part? Actually, let me first erase all this. Initial, that was sigma naught, will be equal to the overburden pressure only. Okay. So, just we will be calculating the overburden pressure for the sigma naught, and what will be the sigma 1? It will be actually equal to sigma naught plus delta sigma, and this delta sigma will be the load or excess or extra load which was found out later on due to the foundation, which is here you can see 1000 kilonewton. Okay. This is the new load which which this clay layer has to bear, or new load, this is the extra load. Okay. So, load upon area at mid clay layer. Okay. This is the formula. Now, we will see how we calculate these two. For effective stress at the center of the clay before the construction. What does this mean before the construction? That is sigma naught. Okay. Means the only the overburden pressure we are calculating. Okay. Do not refer to this figure now, it will be used later on. Just see. Let me roughly make the diagram which was given in the question. It was clay here, sand here as well. Okay. And what was the gamma? This was 2 meter, this was 2 meter, this was 3 meter, and gamma here was 16, okay, kilonewton per meter cube. What was the gamma here? Water was here. So, general gamma is only given, we are not given with the saturated, okay, remember that. So, general gamma was given 20 kilonewton per meter cube, and what was here? Here also only the gamma was given, that was 19 kilonewton per meter cube. Okay, this much things were given to us in the question. Now, let us calculate the overburden pressure. This is the overburden pressure. Okay. So, gamma 1 H1. What is gamma 1 H1? Let us take it as first layer, this will be the second layer, and this will be the final or the third layer. So, this is for first, this is for second, this is for third, these expressions. Okay. So, for first layer, let us see gamma 1 H1. This is the sorry, this is the, we can say, stress, okay, at this point, okay. So, what will be it? H1 is 2 meter, gamma 1 is 16. So, 16 into 2, it will give you 32 at this point. Again, now we require at this point, okay. At this point, what will be it? Now, you can see the water table is here, means this sand is fully saturated, or this part is submerged and this also is submerged, both of them are submerged. So, we need submerged unit weight, gamma submerged we need. What was gamma submerged? It was gamma saturated minus gamma W, gamma saturated minus gamma W, and these are the saturated unit weight. Okay. These are the saturated unit weight given to us. So, gamma saturated minus gamma W, gamma saturated minus gamma W, both them of them. So, gamma submerged here and gamma submerged here is calculated like this. Okay. How? Gamma saturated minus gamma W. Okay. Then H2 is 2 here. Remember H3, I already told you that we will be calculating at the mid of the clay layer, which means this is 1.5 meter. So, you can see it is used 1.5 meter only. So, finally, let us sum it up. Gamma 1 H1 means 2 into 16 plus 20 minus 9.81 due to the submerged weight into 2, and again 19 minus 9.81, which is this formula, into 1.5. So, we will calculate this to get 66.165 kilonewton per meter square. Okay. This is your overburden pressure initially. Okay. Now, let us move forward, we have to find the other parameters. Now, this will be the excess or incremental, okay, which I was talking about, the incremental pressure increase due to this 1000 kilonewton. I told you what will be the formula, load upon area of load bearing at mid of clay layer. Okay. So, we will be calculating first of all load, you already know, this part we have to calculate. Now, let us refer to this figure. Let me remove all this. Now refer to this figure. Okay, now we will be using this figure. In this diagram, if you see, this is the base of the foundation, which was 2 meter. Okay, corresponding to this, obviously this also will be 2 meter. Okay. Now if you remember what is the written in the question, you can see 2 vertical and 1 horizontal load dispersion is to be used. Okay, use 2 vertical and 1 horizontal load dispersion. Okay, 2 vertical and 1 horizontal. So you can see 2 vertical, 1 horizontal, 2 vertical, 1 horizontal. Total height, how is this 4.5 have come? You can see here, erase all. This is from here we have to calculate, I have already told you. So this much, this was 1 meter and this is 2 meter. Here at the middle we are calculating, so this is 1.5 meter. So 1 meter plus 2 meter plus 1.5 meter, which comes out to be 4.5 meter. Okay, is it fine? So this is the 4.5 meter depth. Now for 2 parts or 2 vertical, 1 horizontal is to be drawn. So directly we can say that from 4.5 by 2 will be this much, here also 4.5 by 2. Okay, means for 4, if it was only 4, 2 would have moved. Okay, again, but there is 4.5, so it will be 2.25, half of this and half of this. So this will be this much and this much at both sides. Now add this whole layer, how much it will come? 2, this one plus 2.25 for this one. Now for this one 2.25. So what is the sum? 2 plus 2 plus 2, 6 and 6.5. Okay, this is the only front view. Again in the sidewise also the same dispersion will take place, because it is a square footing, 2 cross 2 square footing was there, if you remember. So now we will be having 6.5 cross 6.5 load dispersion. Okay, so we will be having 6.5 cross 6.5 load dispersion. So you can see 2 plus 4.5, 2 plus 4, which means 6.5, 6.5. So finally we have 1000 upon 6.5 into 6.5, which gives you whatever the value is, 23.67. So like this we have calculated the extra load or extra stress which is applied to that mid of the clay layer due to the increment of the load, which is 1000 kilonewton. Okay, this is the concept here. Then finally I already told you that this formula will be used. Just put in the value, you have all the values now. This we have already calculated, this is from here only. Okay, h naught you know 3 meter, which is converted to millimeter here. E you know, calculate to get the answer in millimeter, which is 86.2. This is the settlement, final settlement due to this load or this incremental load. Okay. Now let us move to the next question. Now this is, we have calculated a question, or we have used a question to find out settlement. Now let us find out the time or time factor or time. Okay. So in this part, first of all read the question carefully. A 6 meter thick clay layer is drained at top and bottom, means double drainage. The coefficient of consolidation means CV is also given to us. Determine the time required for 50% consolidation of the layer due to an external load. So CV is given to us, U is given to us. Now what we are to find? Just we are to find T 50%. Okay, we have to find this, means time required for the 50% of the settlement to take place. Okay, we have to calculate that only. Now you know, for 50%, this formula you know already. I have already told you that when u is less than or equal to 0.6, what will be the formula for TV? It will be pi by 4 u square. So the same is used here, because we are talking about the 50% consolidation. So here we got 0.197. Okay. Then double drainage. So what will be the value of h? H by 2. So it is 3 meter. Okay. Finally, the formula or you can write it h square. Okay. This will be for 50. Okay. So, this also we have calculated for 50. So, what we need T 50 will be T v for 50 into h square upon C v. So, you have calculated this, you already have calculated this is given in the question, just put the values and find out the answer as 410.4 days. Okay. If you want, you can also convert this into days and hours also. Suppose 410 days and 0.4 into 24. Okay. This much will be the hours. Okay. This is the solution for this question. Now, another question, let us see. We again will be finding the time, okay, for different conditions. So, let us see the question. In a laboratory consolidation test, a 2.5 centimeter thick sample of clay layer reached 60% consolidation in 17 minutes, okay, under double drainage condition. Determine the time required for 60% consolidation of the clay layer if this layer soil in the field under the following conditions. 3 meter thick layer of the given soil is sandwiched between two sand layers. 5 meter thick layer of the soil is underlain by sand and underlain by deep layer of intact shell. Means just we are differing or we are just using different conditions for the drainage. Okay, here it is sandwiched between two sand condition, means this is the double drainage. Okay, this is the double drainage, and here there is intact shell which is an impervious kind of rock. Okay, and this is the sand layer. So, this is the single drainage. Okay. Now, let us see the question. We are given with u and t already. Since there will be the double drainage, so it is 0.125, we just halved. Now, for 60% consolidation, we will be calculating the formula, we will be using the formula and calculating it to be 0.286. Okay. This you could have also calculated from T v is equals to pi by 4.6 square. Okay. Because this formula is valid up to, or we can say u less than or equal to 0.6. So, equality is also here. So, we can also find this from here. Then finding out C v, the same formula, T v into h square by t, just putting the value we get C v value. Now, for part 1, drainage at top and bottom. Okay, drain at top and bottom. So, h will become half, as I already told you. This is the condition because sand is pervious. So, it will act as double drainage. Okay, this will act as the double drainage condition. So, h will be by 2. So, this much. Again we have to find t. So, 60 you have calculated, h you know now, C v you have calculated, just find out that t, the as previous question same. Okay. In the next part, it is only drained at top only. Why? Because at bottom there was intact shell. Okay, this is an impervious rock, hence it forms a single drainage condition, and so h will remain 5 meter only. Again use the same formula and get the value of t. Okay. Just this you have already calculated. Now, h will remain as this only. Okay, and C v is the value you have already calculated in the last slide. Okay, the same. Okay. So, just find out the value in days, that is it. So, we have calculated all these parts. Okay. So, this was it. So, in this presentation we have calculated different conditional time of settlement, and also we have calculated this settlement, okay, means the degree of settlement. So, in the next class we will now study the new chapter, that is permeability of the soil. Okay, we will go through the different types of permeability, how they are affected, and what are the different permeabilities corresponding to the parallel and perpendicular conditions of this soil layers. Okay, so just we will meet in the next class. Please keep watching the videos. Thank you.